Now, multiplying polynomials, we're going to start with multiplying monomials to get the hang of what's going on. Now, first thing we need to remember is this is not addition. The rules are slightly different, so we want to be careful. Because with addition, we have to make sure they're like terms. With multiplication, that is not the case. So how do we deal with a 2x times a 4x squared? Well, we multiply the terms times the terms. So 2 times a 4 produces an 8. Then I have an x times an x squared. Do you remember how we multiplied like bases with different exponents? That becomes x to the addition of the exponents. So that's x to the third. Because there's understood 1 on the x to the x right there. So it's x to the first times x squared. Another way we can look at that if you want is we can write these all out. This becomes a 2 times an x times a 4 times an x squared. We can regroup those terms by commutative property. So it becomes 2 times a 4 times x times an x squared. And there I think you can see 2 times 4 is 8. And x times x squared is x cubed. Let's look at another one and see what this one looks like. Negative 10x to the 6th. Let's multiply that all by 6x to the 10th. Same type of an idea. Let's multiply the coefficients to each other first. Produces a negative 60. And then we want to look at the variables. I have x to the 6th times x to the 10th. How do we deal with that? Well, it's x to the 6th times x to the 10th, so we add the exponents. I know there's going to be times that we just want to multiply the exponents and get x to the 60th. That's going to happen because we're going to forget sometimes what we're doing between addition and multiplication. Because sometimes there's going to be problems we're doing with both. And again, how I mentioned at the beginning, what if we had negative 10x, 6 plus 6x to the 10th? That's an addition problem. Can we do anything with this? We can't. Because in addition, we have to have like terms. X to the 6th and x to the 10th are unlike terms, so this cannot be simplified any further. But if we were to multiply those two terms, yes, then we can.